Lever lift, grades 4 through 6. Okay, you're going to have background information on the importance of a lever. You just want to tell the students that levers are machines, a type of simple machine used to increase force. There is a diagram here on the second page, and it just shows you the parts of the lever and important definitions. Okay, so a lever consists of a rigid bar, which in this case is going to be this piece of wood. Okay, it's going to rest on a fixed support known as the fulcrum. Okay, so this is a fixed point in which the lever can turn or balance. The load is going to either be these weights or a string attached to 10 washers. The load is the weight of the object that will be moved. The effort is some type of force. It's either going to be a push or a pull needed to move these loads. All right, so there are 3 different types of classes of levers. We're going to go through each one. Okay, this is the first class lever. What you're going to do is you're going to place the load on the end of the wooden lever, which is letter A. Now you're going to place the fulcrum, the letter D, and you're going to push your finger down at the X. What happened? Well, you just made a first class lever. Notice that the first class levers, the effort and the load is always moving in opposite directions. Okay, the fulcrum is the marker or the pencil, the lever is the wood, the load is the weights. All right, now we're going to move the pencil to letter C. Now push your finger down on letter G. Did it take more or less effort to lift the load? Well, it took a lot less. Now we're going to move it to E. Push your finger down. Did it take more or less effort to lift the load? It took more. Okay. Then we're going to move it to F. And then press down on G. It took a lot more effort to lift the load. What part of the machine were you moving? Well, we are moving the fulcrum. The further away the fulcrum is from the load, it's going to be more effort to move. Now we're going to move, this is activity 3, we're going to move the pencil to the letter D, or the marker. Now push your finger down on G. Now push your finger down on E. Did it take more or less effort to lift the load? Well, when I'm letter E, it takes more effort. Now push your finger down on F. Did it take more or less effort to lift the load? Well, it took less. What part of the machine were you moving? Well, I am moving, not the fulcrum, but I am moving the effort. It's that force of pushing.
Just delete it.
No, that's okay. Okay, so now we're going to move on to activity 4. We're going to leave the fulcrum or the pencil or the marker under the letter E. Now we're going to leave the load on the X between A and B. Now we're going to push your finger down on the G. Okay, now we're going to move the load to C. Push down on the letter G. Did it take more or less effort to lift the load? Less. Now move the load to the D. Push down on the letter G. Did it take more or less? Less effort. What part of the machine are we moving? We are moving the load. Okay. Now move the load to E, right on top of there. Push down on the letter G. Were you able to move the load? Yes, we were. Does the fulcrum have to be in between the load and the effort in the first class lever? You can move it, but it just kind of teeter-tots. All right, second class lever. Remember in the first class lever, the fulcrum was always between the load and the effort. So now it's going to be different. What you're going to do is you're going to set up a second class lever where the effort and the load move in the same direction. All right, so we have several of these spring scales. Please remind your students that these are very delicate. Do not pull on the spring, otherwise it will break and not read accurately. Okay, again, they go 0, 0.1, 0.2, 3, 4, 0.5. Right here, same thing. We're going to look at the newtons. This is 1, 1.2, 1.4, 1.6, 1.8, 2.0 newtons. All right, so what we're going to do is we're going to set it up. We're going to take a little piece of tape. How are we doing, Reed? Good?
Good.
All right, we're going to take a little tape. This is going to be the fulcrum. I'm going to put it right on here. Okay. You can add a little bit more tape. We're going to put the set of washers right here between C and D. And then I have a loop. All right, so what we're going to do is we're going to place the loop of string around the lever just in front of G. Now you're going to tape the string onto the underside. You can go ahead and tape this if you would like. I'm not going to do that. And then you're going to take your spring scale and you're going to try to lift the load. How much force is needed in newtons to lift the weight? Okay, well, it looks like it is 1.1 newtons. Okay, now move the weight to letter D. Okay, and then you're going to just go ahead and record this. 1.3. Letter E. Oops. 1.4. And so forth. We can even go further. F, 1.5. So you see the trend. As the weight goes closer to the force, it's going to increase in newtons. Okay, did the weight move in the same direction you were pulling or the opposite direction? It moved in the same direction. What is the fulcrum of the lever? It's the tape. It's the pivot point. What is the effort of this lever? It's going to be the balance. What is the load? It's going to be the weight. At which position was the load easiest to lift? Okay, well, let's try this again. C is pretty easy, and let's compare it to F. F is the hardest. So the easiest to lift would be C, and the hardest position would be E. Or, I'm sorry, E.